Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Ness. I am with Embedded Computing Design. My guest this week is Window Snyder, and she is the founder and CEO of Thistle Technologies. How you doing, Window?
I'm doing all right. Thanks for having me.
My pleasure. So, in full disclosure, we were together on a panel not too long ago at an event for Infineon, and I was rather enthralled by what you not so much what you had to say, but how you said it and your passion for security really comes across like you really care about this stuff. So I thought I wanted to share all that stuff with our audience. So before we get into the security part and how you do it and why you do it, just a little bit of background. Tell us who Thistle is and what have you been doing for the last, I don't want to date you, but number of years.
All right. So Thistle Technologies builds software, tools, and libraries and backend services that allow embedded developers to incorporate sophisticated security capabilities into their product projects really quickly and easily.
Okay. And you yourself, what's your history?
Sure. Prior to starting this company, I was the chief security officer or the CISO at a number of companies, including Square, Fastly, Mozilla. I was the chief software security officer at Intel. I owned all the security and privacy features for iOS and OS 10 at Apple for almost 6 years. I owned the security sign off for the Windows operating system while I was at Microsoft for a number of years. I was a security software engineer, a security researcher, a security consultant. I've been in the space for over 30 years and have kind of seen a lot. And in my role at Intel, I got to see that despite all this work that we had done in the industry for general purpose operating systems, a lot of the things that we know how to do to make platforms systems more resilient hadn't made its way over to the devices space. And that's the core of what we're doing at Thistle Technologies. We're trying to make those capabilities easy to incorporate.
Okay. Uh, I'm going to come back to that because easy is just something that's not easy. But you started Thistle when?
About 5 years ago.
Okay. All right. So many people do security from the MCU vendors themselves on all the way down. Some people say you need hardware, some people say software, some people say you need both. What are you doing that's different from what everybody else is doing, and why should somebody trust you?
So you're absolutely right in terms of like you need all kinds of things in order to build resilience in a system. But what you really need depends on your security requirements and trying to understand what your project actually needs, what's justified. For devices is really different than for software because devices might live out in the world for 5, 10, 15, 30 years if we're talking about an MRI or a car. So it really depends on what you're building. So that's the first step. And then the second aspect of this is that the threats continuously change and how we use it also changes. So that's another thing. So trying to build something that is going to be resilient for the lifetime of the device is incredibly challenging. And that's why we want to make these low-level capabilities that allow you to establish a hardware root of trust easier. Because if you, for example, let's take update, right? If you can't update your device, then you're never going to get to a place where you can address a security issue and maintain security resilience, right? And you might have an update mechanism, but like, do you have an update mechanism that you're confident enough to ship a fix for, right? Because if that device doesn't come back up, then it's potentially lost forever, right? If we're talking about a 2% failure rate, a 3% failure rate, and we know for a lot of devices, the failure rate can actually be way higher than that when we're talking about update, because we're updating really low level components, we're updating firmware, we're updating drivers. The set of things that can go wrong is significant. So having an update mechanism that is reliable enough that you're willing to push out that update to address that security issue, that is a foundational security feature. And a lot of folks don't think of update as a security feature. They think of a fix being the security component. Update is just, plumbing, but that plumbing is actually critical to being able to deploy these updates. So update is one of the first of these. But establishing that hardware root of trust, being able to tie your crypto operations back into this hardware capability or to a key that's protected by hardware is incredibly important if you want to, let's say, have confidence that the update came from someplace that you're able to recognize. Like you want the device to be able to recognize the device came from someplace. And when the code is executing on the system, you don't want it to execute if it's not the code that the device recognizes. So we start getting into things like secure boot and establishing a secure execution chain and building what we call the security um, supply chain, right? Making sure that you first of all know where it's coming from, and that only the things that are supposed to execute on the device execute on the device. And all of the security plumbing is incredibly difficult to do. And for folks that build, let's say, security for devices, that encompasses all kinds of stuff. They might be building authentication, or they might be building the equivalent of an IDS, looking for, let's say, anomalies happening on the system that might be somebody trying to do something malicious on the device. But establishing these fundamental resilience capabilities allows you to do everything else. Nothing else matters if you don't have that resilience built into your device.
Excellent. Uh, Most of the experts who I speak to say that it's impossible to build a system that's 100% secure, that you just want to make it hard enough that the bad guys will just go elsewhere. Do you believe that as well?
You can't make a system 100% secure. That is absolutely true. But you can make it secure enough for your requirements, right? So if you are, let's say, trying to meet your CRA regulatory requirements, that might be the requirements for your system. If you're trying to meet your customers' expectations, that might be the requirements for your system. If you're trying to build a system that is going to be resilient enough that you can deploy it and believe that it will be operable in the field for 20 years, right? You're going to have different security requirements. If you're trying to thwart nation state actors, that's a whole other thing. If you're trying to deploy a device out there that is going to have your AI model executing at the edge on a device that is in an environment that you don't control, right? And you want to protect that IP, you've got a different set of requirements. So you can do work that is appropriate to achieving the security requirements you have for your
Mm-hmm.
system. And of course, nothing's ever 100% secure, but you can get to a place where you have, let's say, a sufficient degree of confidence that your product will be able to do the work that it's deployed in the world to do safely.
Do we kick some of this back to the user? I mean, it's obvious that things need to be updated once they're out in the field. Does that onus go back onto the user to make sure that devices are up to date, or is that on the vendor to make sure?
So product teams love to put this on the on the users. And I think as an industry, we're moving away from this because it's not really fair. But I'm sure you remember guidance like, oh, be sure you know where this link goes before you click on it, or things like that, right? For an email, like make sure you trust the sender before you blah blah blah. No, you should be able to evaluate whether or not this is coming from where you think it is. It should be hard for someone to
Mhm.
spoof an email from wherever. A link that you click on should be safe, right? It's not the it's not the user's responsibility to evaluate whether or not the link is safe, no matter what these IT teams tell their folks. It should be that the OS is smart enough to evaluate whether this is going to do something malicious to the system. And all that's incredibly difficult. I know we talked a little bit about making things easy, but easy is hard. Easy is incredibly hard. It would be really hard to create a system that is so resilient that the user could accidentally install something malicious on their system, and the system goes, that's a terrible idea. We're not going to let that install. We're going to flag it for you. We're going to let the IT team know. We're going to prevent that from executing. Instead of like the model we had about 10 years ago, which is that you click on something and the next thing you know, not only is your system compromised, but the entire infrastructure for your organization is compromised. Oops, right? Like easy is hard, right? But you can get to a place where you've got a degree of security resilience where instead of, let's say, the onus being on the user to keep their infrastructure up to date so that the attack surface that's exposed on this network isn't as accessible to the attackers, like, yeah, okay, it does matter how you deploy it. That's fair. But staying up to date, like, are you actually shipping an update? Is the update um, uh, let's say, reliable enough that the user has confidence that they're not going to have downtime with the system? Like, if we're talking about industrial manufacturing, that is like real time on the line that the system is down, and that's money, right? If we're talking about point of
Mhm.
sale system for a
Yep.
large a retail environment, that's revenue that's just lost, right? If we're talking about a car in the field that has a problem with their update, they have to come back to the dealership, and we've seen that happen over the last year. We've had updates that ship out that cause problems that require the car to come back to the dealership for a fix. If it's a phone, right, we've got 100 million devices out there. That's potentially with a 1% failure rate, a million devices that have to come back to the mobile store or to a provider, because very often the user can't get that up and running themselves. Like it's not a simple thing. It's not easy. Easy is hard, but easy is still what's required. We need to make security easy so that the onus isn't on the user, even if we're talking about consumer products, even if we're talking about
Mhm.
um, devices that are deployed into environments that have an IT team that is available to fix these things. If we're talking about devices, they're out in the world doing a job, right? It might be a consumer device, in which case there's maybe a smart home network that they can rely on for some mitigations. But for the most part, we just have to build systems that expect the worst, that operate in spite of all the things that can go wrong, and that are able to be reset to a known good state, so that you can build that confidence again back from hardware that the things that are executing on the system are the things you expect as a user or as a device manufacturer, and that you can manage those devices so that they are able to you're able to recognize that they're in a known
Mhm.
good state.
Very good. So you mentioned earlier about how embedded devices are often deployed 5 years, 10 years, 20 years is not that uncommon. So what do we do about some of these devices that have already been out there for 20 years and we know aren't built to the levels of security that we need? Do we just keep our fingers crossed and hope for the best? Or is there some solution?
So one of my favorite painful moments was, I think it was last summer when the FBI released a report about a bot network that was operating through home routers and cable modems, and hundreds of millions of devices were compromised, and they were actively being used to exploit other systems as part of this bot network. And the only guidance they could give to folks if you own one of these routers was to go buy another one, which is infuriating, right? That's infuriating. But it's true that for these devices that might have deployments in hundreds of millions, that the option to update, even if they're able to ship an update for it, which maybe they are, maybe they aren't, but if they're able to ship an update for it, but they've got like a 1% failure rate, which is low, it's probably closer, it's probably in double digits, but let's just say it's a 1% failure rate. That's a million devices that are calling in and say to their internet service provider saying, my internet is down. And then the answer for those folks is to be like, don't worry, download this firmware update, use a USB cable, plug it into your computer, plug that into the router, and do a firmware update over USB to blah, blah, blah. How did they even download the firmware update in the first place, right? It's a completely unreasonable prospect to try and get those devices back up to date if they fail. So the FBI is left with being forced to give guidance like go buy another one. That is terrible. That is absolutely terrible. That's not what we want. We do have to figure something out for brownfield devices. And there are folks out there who are doing things like trying to um, uh, deploy them in air gap networks, or put things in front of them so that they are
Mhm.
less likely to receive input that's unvalidated from malicious sources. Um, there are some things that we can do. And for devices that actually have a shell, there are some options that we will be working on later for adding security kind of after the fact for the devices that are already in deployment. But we're all builders, right? We're building stuff today, right? So we can avoid making the same mistakes in the future that we've made in the past and move forward uh, with a much more resilient security infrastructure for which to build on, because we know that the threats are going to constantly change, that they're going to evolve, and so far they've only gotten worse. So far they've only gotten worse in terms of like the amount of folks that are invested in compromising these devices, these systems. It's these are high value systems. They're connected to real world physical systems that have real world physical impact, and whether that's human safety or that's national infrastructure. Um, there's there's a critical reason that we need to do this work now, so we don't end up in the state 20 years from now still going, oh no, what do we do about all these this past 20 years of brownfield devices? We have to do the work.
Awesome. This is very interesting and not an issue that's going away anytime soon. I fear it'll get worse before it gets better.
Well, some part of it is getting better. It's getting easier to incorporate these capabilities, and that's what I've been working on, trying to just make it easier to get these capabilities in place because it's hard. So we're trying to make it easier.
Very good. Well, thank you, Window. I do appreciate you taking the time to educate the audience.
Absolutely. Thanks for having me.
That was Window Snyder. She is the founder and CEO of Thistle Technologies, and I am Rich Nass with Embedded Computing Design.